Hey guys, welcome back to the next video. In this video, we are going to talk about containers. So before we understand much about containers, first let's understand what is a container. Now, to give you a short view on container, an executable unit of software in which application code is packaged, along with its own libraries and dependencies in a common way, so that it can run anywhere, whether it would be on your desktop or on your laptop or a traditional IT solution or infrastructure or over a cloud. So this is basically what a container is. And to take complete advantage of containers, you need to have an operating system which should be virtualized in the Linux kernel namespace and C grouping primitives, which leverages both isolation of process and control the amount of CPU, memory, and disk that the process have to use. So this I'm talking about is it could be on a virtual machine on your laptop. It could be, in my case, it's going to be a virtual machine on my laptop. It could be a cloud-oriented server, which you're taking, like a large server you're taking, and you want to deploy a container on that. That also is possible. Here, if you want to have a blade server and you want to install container on top of that by installing an operating system on that, that is also possible. Now, what is needed is that you need the virtualization technology, which is going to be part of your Linux, like namespace and C grouping, which is going to be by default on these days operating system. And using that those two kernel operatives, you will be able to namespace enables you to isolate the process, and control group enables you to control the and group the amount of CPU, memory, disk, and other processes which is required for your containers to run. So that's basic thing. So these are what you see on the screen is basically isolated process, managed independently, and featured special layered file system. We will talk about each of these concepts further down the videos, talking about containers, because those are the fundamental blocks for having the containers created. Moving on, containers are so small and fast that are portable, unlike virtual machines. Containers doesn't need to have a guest operating system, the complete guest operating system, which we have already seen in the previous architecture, how a guest operating system is and how heavy is the guest operating system is. The advantage is that you don't need such a guest operating system in terms of working with containers. And you're going to have what is required for that particular piece of image. You're going to have a layered image of operating system, and then on top of that, you will be installing multiple other softwares. We will talk about the layers a little further ahead in terms of understanding the layers and then doing the hands-on for the layers as well. Well, that's so much for what is a container. Now you understand the container. Container is basically the very tiny bit of what you're going to use. Now the next one is we are going to talk about is benefit of using a container. So the first benefit is that it is lightweight. When you talk about lightweight, the container shares a machine operating system kernel. So which means that it's not going to have everything about the operating system. It's going to have the key part of running your Linux server. That's the kernel. And thus eliminating the requirement for installing the full operating system instance. For example, if you download CentOS, it's about 10 GB, CentOS streamline upstream. So, but if you download the same CentOS in a container format, just 300 MB. Now, how can you make a 10 GB to 300 MB is by removing all those services which is not required for you to run most of the service. So which means that you're going to have a base operating system where the bin bash will be installed, bin sh is installed, where you can actually log in into the container, do some activities like you will have the basic commands like ls, dir, make directory. So likewise, you will have the basic commands. But then if you want to build something on top of it, you can do so. That option is always available by adding more layers on top of it. by using yum repository and then installing the components. Even the yum repositories won't be there. So the repository folder on yum is empty. Now, we have never seen such an operating system so far in all our trainings where yum would run to install and install the components, right? Now, when you install this container like base version of CentOS 9 upstream, you will not even see yum as part of it. So which means that you can understand, this tells you how the level of customization done on that operating system. So that's basically how lightweight is achieved in terms of removing all those unwanted objects and softwares from your operating system and having the base operating system which has the OS kernel and those commands which you need to run to make your life smooth. Okay, so that's the only thing. The smaller size, especially compared to virtual machine, means that it can spin up quickly. The boot up time of a machine is much faster. First thing, to replicate it to another server, to copy that or to use the same image and create another machine is going to be much faster because 300 MB is not much of a replication, right? So if I copy a file from 300 MB from this disk to that disk, even hard disk drive takes much faster time. So think about hosting that on a NVMe or a SSD kind of technology where the transfer of these files will be like nothing. So the smaller size is going to give you a lot of advantage to work with your containers. So that's very important. The second thing is portability and platform independence. So you can have this container running anywhere, which any tool which can use or build or use an open container image. So which means that there is open standards for your containers. So which means that there is open standard, meaning that this is all part of Cloud Native Foundation community. So which means that whatever we are doing is all open source. So when you create a container, you can actually take that container and put it anywhere. They take the image of the container and put it anywhere. And anyone like Podman, your OpenShift, any other container can use this particular container which is created or the particular image which was created or the container if you want to take it. But no one transfers the container, they just take it from the image because image is much easier to transfer and you can spin up multiple containers from image. So that's another thing. We will understand more about these concepts later point of time. Don't worry about it. I will not go without explaining you all these concepts because it's much important for you to work with the OpenShift. The next one is all about supporting modern development and architecture. Now, this enables this containerization where your application is going to be modernized. The modernization process is going to happen through microservice. A microservice and DevOps serverless are some of the concepts which is called modernizing your environment, which basically is how you update your codings accordingly. So when you modernize your development and architecture, you will be able to see the DevOps serverless concepts coming into the picture. And this enables you to have your application supported with a container. So due to containerization of their deployment, portable and consistency across platforms, and due to their small size, containers are ideal fit for modern development and application pattern, which I told you is about DevOps, serverless, and microservices. In terms of improves utilization in terms of that, how you're going to benefit containers is that, like virtual machines before them, containers enables developers and operators to improve CPU and memory utilization of a physical machine, where container goes even further. Further, how it goes further is because they also enable microservice architecture, and even it is even smaller than virtual machine. So you can even control. I will tell you about this when we talk about microservices. Just bear with me for a second. Yeah, I told you about this concept in microservices where you will not likely improve in terms of the monolithic application. If you remember the topic where we are comparing monolithic with microservices, you will understand that the monolithic application, if you want to scale up, right, on a virtual machine, you need to scale up your entire monolithic application. For example, your monolithic application has product catalog, it has customer review, and let's just say you have payment process or payment gateway. So in that, the product catalog is a mostly used service. But then what happens is like you need to scale up the entire monolithic application with multiple instances where you don't have a control in terms of you are improving CPU and memory utilization in the virtual machine, but then you cannot actually control that particular product catalog cannot be isolated, and only that particular can be scaled up. But in terms of microservices architecture with the combination of containers, you can isolate. Firstly, you will be isolating that product catalog as a different service only in microservices, because you're going to divide that and you're going to individualize that application. It is obviously going to communicate with the customer review and payment gateway, but then that is through API. But then you can scale up these containers where you have your product catalog is hosted. So that kind of a granular level of scaling can be possible when you compare it with the monolithic architecture. So I'm trying to combine both of them together because both of them are related. So if I talk about if I talk about microservices, I have to talk about a container because that's related. It's almost the same. Well, in terms of container life cycles, so what we are going to talk about is trying to understand what are the different life cycles you're going to go through in terms of containers. First, the one which we're going to talk about is acquire. Now, there is an option over here, but it's kind of useless. But then I can show it to you on the hands-on session where we directly run a container and show you that. But it always goes and acquires that. So that basically there is a connection between run and acquire, because by default your system will not have the container image, okay, the Docker container image or whatever the open container image, it won't have it. So which means that it needs to go and fetch it from Docker inventory. So as we're using Docker, so we will be fetching it from the Docker inventory. Docker also connects with other inventories as well, but there are these certified images and non-certified images in which Docker does verify the images, standards and everything else, and then basically certifies that. And mostly those are hosted in Docker itself. And there are other third-party images also, so that we will talk about it later. So when I talk about run, I'm talking about executing a container. So there is an option where you can run hello world, as in like you will go and acquire an image from the Docker container and then run it over here. That's one thing. But then acquire is mandatory because this is the starting of your life cycle. Okay. So when you talk about acquiring, which means like you are going to acquire the base image. Okay. It's one of the concepts of Docker, which is an idea of layered image. So for a layered image, firstly, you need a base image with the OS kernel, right? So that is what I'm talking about here, acquiring the OS kernel. And then the next process is building on top of the OS kernel by whatever the software you need. Or probably you can acquire a software which is already built on top of a OS layer. Remember, I'm talking about three things here. One is running directly an image without even building it. That's one option. So that is a pre-built image. You can acquire and run it. The second option I'm giving you is like you acquire an image and you build your software on top of it. For example, let's say, for example, that I want for some reason, I want Apache HTTP server 4.54. That is the only version I need. But you search the Docker containers and you don't see that particular version, and then you kind of break your head like why you don't see that image right there. Then you have an option of building an operating system, the base OS kernel, and then on top of that you keep your Apache HTTP that specific version 2.4.54, and you download that. You tell the Docker image how to download that image, how to install that image in a Docker file, or you go for Docker Compose and you use a YAML file format and you define that. You either use Docker Compose or you use a Docker file. You tell it how to compile it, and then it downloads, it compiles. So every time it does an action, it creates a layer. You got it? So on every layer becomes read-only. Okay, so which means that you don't modify it. So it builds something on top of it. So likewise, you build something and then you deliver it, deploy it, and run it. Okay. But the third option I'm also giving you is that you already have the HTTP version. So if you are open and you are okay to download and install any version of HTTP, and then you want to put your configuration file on top of that, that's the option I'm talking about. So you have the pre-built image of HTTP server, but it can be of any version of operating system. It can be any version of HTTP server. You cannot be saying that I need this version only. If you need this version, I've given you the option number 2. That's a long option. That's more research and development is required, but it is possible, right? It is possible. So that's basically the way I'm talking about in terms of build. The next one is deliver. Deliver is when you deliver a build into production system. You automate the entire delivery pipeline across your application. You might also include a step for scanning vulnerabilities at this stage. The next process is deploy. Deploy is a process which actually it's part of your continuous deployment, continuous delivery, CI/CD pipeline, where your application will be going into the production as an update. Okay, you need to do a continuous delivery around an application. So you need an orchestrator to replace the old version of the new ones. So there are 2 ways you can do this deploy. One, you can manually deploy it by running a command. Or you can use an orchestrator which can automate this CI/CD. So which means it will continuously deliver and continuously deploy to your application. So you can either use an orchestrator which can automate this process. And the use of orchestrator is going to give you an advantage as well. So there will be an option for you to deploy, which is called rollout. And there is an option for you to roll back. So which means that you can have the option to go back to the previous image also. That is by running a simple command. You can do that when you don't have an orchestrator. Simple as that. Okay. I'll be showing you how to install your HTTP version in a specific version and in a specific way. I will tell you that in the hands-on session. Do not worry about that. In terms of running is the next step. When you want to run, this basically is a command Docker run. So this run step sets a management system and the runtime environment around your container. It basically establishes the container to a runtime. Okay, so that's where you start running the container. So as of now, we've been talking about building an image. Now, image is basically what you call as an ISO. So if you are familiar with ISO concept, ISO is basically a file type, okay, which is for your operating system. So if you download on any operating system, it will download as a ISO file. Now, what is the use of ISO file? ISO file is used for mounting the operating system when the operating system boots. So that's ISO file is what we will burn in our CD disk, CD drive, and we will run it at the installation. Later, it became a part of a USB drive. Later, it just disappeared because you don't need a ISO image later point of time. So because the internet is so good that you can download it directly from the internet. So you just have to boot your operating system and then basically does everything from the internet. So these are the steps we have come through. But then ISO file, when I say that, you should be remembering that when you download any operating system, you will get that ISO file, right? So that is basically equal to image, what we have right now. Once we have the image generated, populated, you will be able to run that image and make a container out of it. Now, the container can be run in two ways. Like you can run once, okay, because the purpose of the container is over, okay, like running a cat command. So what is the difference between running a cat command and running a tail command, tail-f? Cat command will show you the file output and the command will exit as like I'm done, right? So that's basically the cat command. But tail-f command, it keeps on looking for updates on the file when you give a tail-f file name. So you can run a container in a background which keeps on running forever until you stop the container with docker stop command with the container name, or else it will just run whatever the command you're executing, it will execute that command and it will quit. That's it. That will exit. So it won't be in the process again. So this is a two-way of running the Docker command. Again, these two different ways of running a Docker command, we will see it on the hands-on session as well. The next one is about maintain, right? The last component is maintain. Finally, the maintenance step is where you get a visibility in your application. This is how you will, your customers will be browsing your application, or you will experience the application, how it works. You kind of understand the application, you get live feedback from the different people using the application. You detect failures on the application, you debug the application, and then you go back to the acquired state. So here, this time, if you're acquiring the same operating system second time, it will not look for the operating system from the internet, okay, from the Docker repository, because it is already downloaded and put that image on your system, right? So it will look for the image on the same system. And then you make an update here, like what actually is the update you require over here in terms of understanding the update. And then you build based on, you build the operating system layer, and then you build those layers on top of it. There is a system called cache system in Docker. So when you kind of do it the same way, it tries to build, if you are using the same Docker file, it will try to build with the same level of stuff. So it will try to continue from where you left off rather than creating a new file. So you have options to ignore that and ignore the cache and create it in a new way. So that is also possible in terms of building. So this is, I'm telling, the second version of your file, okay? Because you have found the debugging problem. You debug the problem, you found the problem, now you need to fix it, right? So you need to build a new image for fixing it. So that's why we're coming to acquire again. We are building that, we are delivering it, we are deploying it, we are running that container, and again, we are testing the application, whether it works fine or not. Okay, so this is the basic step in terms of container lifecycle. So why it is vital for you to understand container lifecycle? Because in OpenShift, we will be using containers. Maybe not using Docker exactly, but we will be using Podman, which is as equivalent to Docker, which works exactly similar to Docker, which uses the similar images as Docker, right? So it's better to understand it with a familiar tool like Docker so that you don't see to hear to learning a different tool. But then we will also do hands-on session on Podman just to understand how the Podman works as well. So you will find it exactly identical. A lot of people, what they do is like, they do a LN. They will create a link for the name of Docker to Podman. So when they execute Docker, because they used to execute Docker, right? So they used to execute Docker, but on the back end, it is the Podman which will be running. I'm just telling you this example to tell you that how similar both are, so that you don't have to really worry about using Docker or Podman, doesn't matter. Okay, so now we have understood about the containerization or containers, now I think we are good to go ahead with the next topic. But if you have any questions, please leave your questions on the question section. Now, do remember that your review really matters to me to make it give you more give you more interactive session, or give you 100% of what I've learned in my career. I think you should respect that by giving a proper review. So that really helps me a lot to get my course, get going, because that is the only way I'm surviving right now. So thanks again for watching, and thanks again for being patient with my explanation. I'm giving a lot of examples for you to make it easy for you to understand. If you think I'm going wrong somewhere, or you need some more explanation on a specific topic, please put it on the question section. I'll be more than happy to help you out and clear your questions. Thanks again for watching us. See you on the next one.